Imagine a massive concrete structure standing under the scorching Italian sun, withstanding earthquakes, floods, and barbarian raids for nearly 2,000 years straight. At the same time, our modern sports superstructures, built using space-age technology, are already requiring billion-dollar repairs after just 30 years. It sounds like some absurd historical anecdote or a very offensive joke aimed at modern engineers. But this is our harsh reality, one that every sports official in the 21st century must come to terms with. Today, we'll take a detailed look at this surprising paradox and understand why ancient builders turned out to be far smarter than us. Let's start by laying out one of the most mind-boggling facts about this iconic structure of the ancient world. The Roman Colosseum could easily accommodate around 80,000 frenzied spectators, thirsty for spectacle and blood. But the craziest part is that this massive crowd could completely clear the building in just 15 minutes. Try to recall your last trip to a major football game or a concert by a popular rock band at a modern stadium. You probably stood for hours in a stifling traffic jam of people, cursing everything under the sun and slowly making your way toward the coveted exit. In this video, we'll take a detailed look at every component of the Colosseum's engineering system, from the foundation to the roof. We'll venture into the dark underground chambers of the Hypogeum and discover how the ancient elevators for wild animals worked. We'll compare Roman technology with the solutions used in the construction of American football stadiums. And most importantly, we'll answer the question of why modern stadiums are built with the intention of being demolished in 30 years. You'll be surprised, but the answer lies not in a lack of necessary technology or high-quality cement. Get ready for a thrilling journey into a world where engineers were true rock stars and risked their lives for mistakes. We'll debunk popular myths, reveal hidden mechanisms, and make you look at familiar stones in a whole new light. I promise that after reading this essay, you'll look at modern sports arenas with a touch of healthy sarcasm. Pour yourself a strong cup of coffee, settle into your chair, and let's unravel the mystery of this 2,000-year-old challenge together. Let's dive deep into the centuries to uncover the greatest secrets of the Roman masters. When you first approach the Colosseum, you are inevitably overcome by a strange sense of your own insignificance in the face of this stone colossus. This gigantic Flavian amphitheater still dominates the landscape of modern Rome, a reminder of the former grandeur of a bygone civilization. Just think about this astonishing fact. The building has survived the fall of a great empire, numerous devastating earthquakes, and endless raids by marauders. Throughout the Middle Ages, it was used as a quarry, a fortress, and even a giant saltpeter factory. But despite all these harsh trials, the skeleton of the structure has remained virtually indestructible and stands proudly in the center of the city. Modern buildings crumble at the slightest whiff of crisis, yet this structure defies all the laws of nature. The most amazing thing is that this entire colossal structure was erected in record time, in just 8 long years. By comparison, some modern soccer stadiums take much longer to build, constantly blowing budgets and pushing back completion dates. The Romans could not afford such a luxury, for the emperor urgently needed to solidify his legitimacy on the throne. Every day of delay could cost Vespasian his crown or even his life in the event of another riot by the starving crowd. Therefore, the engineers worked at the limits of human capability, inventing new methods of rapid modular construction on the fly. We can still admire the result of their titanic labor today as we stroll through the historic center of Rome. Let's look at the raw numbers to fully grasp the scale of this architectural feat by the ancient masters. The length of the amphitheater's outer ellipse is just under 182 meters, and its width is 156 meters. The walls reached a height of nearly 50 meters, which is roughly equivalent to a modern 15-story residential building. The very architecture of the Colosseum served as a visual guide to the social hierarchy of the great and ruthless Roman Empire. And the engineers had to design the building so that these different social classes would never cross paths in the aisles. It was an extremely complex social and logistical challenge, which they handled brilliantly. The key to this mystery lies in details that are invisible to the casual tourist during a cursory glance at the majestic ruins. Every structural element, every arch, and every span was part of the grand master plan of the great architects. They didn't just build a beautiful box for spectacles, they designed a perfect social mechanism for the long term. And it is precisely this systematic way of thinking that allowed the Colosseum to survive the centuries, leaving all modern counterparts far behind. Next, we'll take a look inside this system and examine the first crucial element: crowd evacuation logistics. Get ready to be amazed because these figures still shock global architecture experts. 15 minutes. That is exactly how long it took to completely and absolutely safely evacuate an 80,000-seat stadium. Just think about this fantastic figure, which seems unreal even in our age of high technology. Today, few modern stadiums can boast the ability to disgorge such a mass of people in less than an hour. Usually after the final whistle, spectators are forced to shuffle slowly down endless ramps, jostling one another. The Romans believed that forcing the citizens of a great empire to stand in lines was the ultimate sign of disrespect for their dignity. That is why they created a system that operated with the speed and precision of a well-oiled hydraulic press. Today, at soccer matches, we often see huge crowds of fans causing chaos right at the entrance. Roman engineers anticipated this scenario and divided the flow of people even at the far approaches to the amphitheater. A wide plaza was laid out around the building, paved with smooth stone and surrounded by special dividing posts. This allowed the massive crowd to disperse in advance and approach their respective arches in orderly, calm rows. Modern urban planners call this the management of crowd behavior in space, presenting it as a great discovery of our time. The Romans simply practiced this method every Sunday when they went to watch the latest gladiatorial fights. How did they manage to avoid the horrific stampedes on the stairs that regularly claim lives in modern arenas? The answer lies in the precise calculation of the width of the passageways and the angle of the amphitheater's inner steps. Roman architects applied the laws of hydrodynamics, distributing people as if they were streams of ordinary fresh water. The width of each successive corridor precisely corresponded to the volume of the human mass that was to pass through it. If a passageway narrowed, an additional side gallery would inevitably open nearby to relieve excess crowd pressure. It was a pure triumph of applied mathematics, embodied in rough gray stone and concrete. Interestingly, social segregation in the Colosseum also served to accelerate the general evacuation of the building. Patricians and senators sat in the lowest, most prestigious rows, right at the very edge of the sandy arena. They didn't need to climb high. Their exits led to separate, guarded, luxurious underground galleries. Therefore, the next crucial step was to create a material capable of withstanding this incredible load for centuries. And here the Romans made a true breakthrough that changed the entire face of world architecture once and for all. They invented a material that we now call Roman concrete, and its recipe was lost for many centuries. Let's explore why their cement turned out to be far superior to our modern counterpart. Our modern concrete is a rather temperamental material that begins to gradually deteriorate after just 50 years of use. Moisture penetrates it, causing internal corrosion of the steel reinforcement and slowly breaking down the concrete from within. Roman concrete, known as opus cementitium, is constructed entirely differently and contains no steel reinforcement. In the Colosseum, concrete was not used everywhere, but very selectively and judiciously in areas subject to the greatest loads. The Romans did not pour massive gray boxes as builders of our dreary modern residential districts do. They combined concrete with brickwork and massive blocks of natural stone. Concrete was poured into the interior of the walls, serving as a strong and flexible core for the entire structure. On the outside, this sandwich was clad with beautiful travertine or durable volcanic tuff to protect against external influences. This hybrid structure allowed the building to breathe freely and successfully cope with any deformations. Let's consider our modern bridges and overpasses, which are constantly closed for repairs due to cracks in their supports. Engineers use high-strength steel and polymer additives, but nature still prevails over them within a couple of decades. The Roman concrete in the Colosseum withstood colossal loads from the weight of the building itself and the millions of people who passed through it. However, durable concrete alone could not have saved the Colosseum from collapsing under the immense force of gravity. To distribute this gigantic weight, the architects needed a fundamentally new structural design for the building, and they found it by relying on an element that became the true hallmark of all Roman architecture. We're talking about the famous system of arches that covers the entire facade of the amphitheater in smooth, lacy rows. Let's explore how this simple geometric shape revolutionized construction and saved the Colosseum from gravity. Let's move on to the next chapter, where physics meets the true artistry of the ancient masters. Before the Romans, most of the great civilizations of the ancient world built their structures using the simple principle of a post and beam system. Look at the famous Greek temples or the majestic Egyptian colonnades in Luxor. These are always huge, heavy vertical columns topped by a massive horizontal stone beam. This design looks very beautiful and monumental, but it has one major engineering flaw. Stone performs excellently under compression, but cannot withstand bending or tensile loads at all. If you make the span between the columns too wide, the top beam will simply snap in the middle under its own weight. This fundamental limitation of physics prevented ancient architects from building truly massive enclosed spaces with high ceilings. The Greeks had to place columns literally every few meters, turning the interior halls into a veritable forest of stone. Arches made it possible to distribute the colossal load evenly across the entire perimeter of the stadium's massive elliptical bowl. Each tier of arches rests on the one below it, transferring the building's weight lower and lower, all the way to the very foundation. Modern engineers call this a truss structure and actively use it in the design of steel and glass skyscrapers. The Romans arrived at this design intuitively, using only primitive plumb lines and a deep understanding of the laws of physics. Interestingly, the Colosseum's arches are made of different materials depending on their location and function. On the lower tier, where loads are greatest, the piers are constructed of the strongest travertine, capable of withstanding immense pressure. On the upper levels, the builders used lighter tuff and brick to reduce the structure's overall mass. This made the top of the building lighter and reduced the risk of the walls collapsing during strong earthquakes. The Romans fully understood the importance of properly distributing mass throughout the structure's height long before the advent of theoretical mechanics. Modern science has merely confirmed the accuracy of their intuitive, off-the-cuff calculations. But even the most ingenious system of arches would prove utterly useless if the building's foundation itself began to shift on unstable ground. We recall that the Colosseum was built on the site of Nero's drained lake, where the ground was saturated with treacherous groundwater. To support this colossal stone grid of arches, the engineers needed to create a foundation of unprecedented strength. And they succeeded in this task by laying a gigantic travertine cushion of incredible thickness beneath the amphitheater's bowl. Let's move on to the next chapter and examine how the Romans built a foundation capable of dampening earthquakes and withstanding the test of time. It is a foundation that literally bears the weight of the entire eternity of Roman history. Any experienced builder will tell you that the strength of any house begins with a proper and reliable foundation. If you make a mistake at this stage, all your subsequent architectural refinements will go down the drain very quickly. Roman engineers knew this golden rule perfectly well and approached the creation of the Colosseum's foundation with truly imperial grandeur. They had to set a massive structure weighing hundreds of thousands of tons on the bottom of a swampy pond. An ordinary person would have given up in the face of such an impossible task and moved the construction site elsewhere. But the Romans weren't looking for easy solutions and decided to completely reshape the geology of this plot of land. First, the workers dug a gigantic elliptical excavation pit, the depth of which reached an impressive 12 meters below ground level. To prevent the pit walls from crumbling due to moisture, they were reinforced with massive retaining walls made of durable, water-resistant concrete. Millions of liters of groundwater were completely pumped out of this enormous pit using special Archimedes screws. After that, engineers began pouring a colossal, monolithic foundation ring that filled the entire underground space. The thickness of this gigantic concrete cushion was an incredible 13 meters, equivalent to the height of a 4-story building. It was the most massive continuous concrete pour in the history of the ancient world, truly mind-boggling. Every ton of travertine brought from Tivoli was an investment in the eternal glory and indestructibility of the Roman state. And this investment has fully justified itself, having withstood the test of centuries and the rigorous scrutiny of relentless time. Modern builders would do well to learn such strategic thinking from their distant ancient colleagues. A solid travertine foundation allowed engineers to create something completely unique and breathtaking above it. We are talking about the famous Hypogeum, a gigantic 2-story underground labyrinth hidden beneath the arena's wooden floor. It was a veritable factory of death and illusions, where the spectacular elements of every grand Roman show were forged. The Colosseum's underground metropolis lived a life of its own, turbulent and dangerous, ensuring the smooth operation of the upper tiers. In the next chapter, we'll descend into these gloomy underground passages and examine how the ancient elevators and hatches worked. Get ready, because this underground engineering will amaze you no less than a human flight into space. What the average spectator saw from the Colosseum's stands was merely the beautiful, ceremonial tip of a massive iceberg. The true engineering marvel and highly complex mechanics took place deep beneath the arena's wooden floor, covered with clean yellow sand. This underground complex of labyrinths, corridors, and chambers received the official scientific name Hypogeum. Strictly speaking, during the reign of the first emperor, Vespasian, this underground complex did not yet exist in its current monumental form. It was built a little later by his son, Emperor Domitian, who decided to transform the arena into a technological theater of special effects. He replaced the temporary wooden supports with a permanent system of stone walls, corridors, and lifting mechanisms. Imagine the vast backstage area of a modern metropolitan theater, magnified by about 100 times in size. Thousands of people were in the Colosseum's Hypogeum at the same time, gladiators waiting for their entrance, frightened slaves, animal trainers, and guards. The Romans had no electricity, but their elevators operated flawlessly thanks to reliable muscle power and the laws of physics. If one slave collapsed from exhaustion, his place was instantly taken by another from an endless reserve of manpower. This system possessed 100% fault tolerance, which even the world's best modern concert venues could genuinely envy. But the Hypogeum was not merely a storage area for props and cages. It was a key element of the building's security logistics. Through underground tunnels, the Colosseum was directly connected to many important sites located beyond its walls. The most famous tunnel led to the Ludus Magnus, the largest gladiator school, located a couple of 100 meters from the amphitheater. Fighters could enter the arena directly from their barracks without crossing paths with the rowdy crowd of fans on the street. This eliminated the possibility of assassination attempts, escapes, or spontaneous mass riots surrounding the main protagonists of the event. Other tunnels led to the Imperial Palace, armories, and a massive morgue for fallen combatants. However, in addition to underground secrets and crowd logistics, the architects faced another critical practical problem. Imagine 80,000 people sitting on stone stands under the scorching, merciless southern Italian sun. Without reliable protection from the heat, the stadium would very quickly turn into a giant, scorching oven for roasting people. To save the citizens from heat stroke, the Romans developed a unique system of air conditioning and sun protection. Let's move on to the next chapter and examine the famous Velarium, a giant awning operated by actual naval sailors. It was a spectacle that amazed contemporaries no less than the bloody gladiatorial fights themselves. The Italian summer can be incredibly harsh, heating the stone streets of Rome to 40 degrees in the shade. Sitting in the open marble stands of the Colosseum for several hours straight in such weather is a truly sophisticated form of masochistic entertainment. People could easily suffer severe sunburn, dangerous heat stroke, or simply pass out from the stifling heat. The emperors understood perfectly well that a dissatisfied and overheated crowd becomes extremely aggressive and difficult to control. To ensure maximum comfort for the citizens, a grandiose sun protection system was created. the likes of which were unmatched anywhere in the world. We're talking about the Velarium, a giant fabric canopy that could completely cover the entire bowl of the massive amphitheater. Imagine a massive sail the size of several football fields, stretched 50 meters above the stands. This canopy was made of durable, lightweight linen or expensive canvas, dyed in bright imperial colors. In the very center of the canopy, there was a large circular opening to allow sunlight to reach the arena floor. Thus, spectators sat in pleasant, cool shade, while the fighters remained well lit for everyone to see. Stretching and properly adjusting such a colossal, sail-like structure was a task of incredible engineering and logistical complexity. Ordinary civilian builders were no match for this problem, so the Romans brought in true professionals. Let's compare this ancient Velarium with the retractable roofs of modern multi-purpose stadiums around the world. Today, engineers use heavy steel trusses, powerful electric winches, rail guides, and weather sensors. Building such a high-tech roof adds hundreds of millions of dollars to the project budget and delays construction for years. And yet, modern retractable roofs regularly break down, get stuck halfway, and require exorbitant amounts of money for maintenance. The Roman awning worked flawlessly, was operated by hand-cranked winches on the ground, and didn't consume a single kilowatt of expensive electricity. This is an example of the ingenious use of natural resources and human skills to solve an extremely complex climatic challenge. It sounds strange, but the Velarium also helped improve the acoustic properties of the huge open-air stone amphitheater. The fabric stretched over the stands acted as a giant sound screen, reflecting people's voices and shouts back down. Thanks to this, the roaring crowd of 80,000 voices created an incredible, deafening sound pressure on the fighter's psyche. The sound did not vanish into the empty sky, but concentrated within the bowl, amplifying the atmosphere of a grand celebration. Designers of American football stadiums are still trying to recreate this acoustic effect by building special sound canopies. The Romans got this amazing bonus completely for free, simply by solving the problem of protection from the scorching sun. Passive climate control and sun protection made the Colosseum as comfortable as possible for people from all walks of life. But spectator comfort was only half the story, as the stadium required an enormous amount of water to function. Water was needed for drinking, to flush thousands of toilets, to clean the arena, and even to stage actual naval battles. The Colosseum's engineers created a fantastic water supply and drainage system that still amazes hydraulic engineers today. In the next chapter, we'll examine these waterways and understand how the stadium could transform into an artificial sea. Get ready, because Roman hydraulic engineering represents the pinnacle of the ancient world's engineering art. Water in ancient Rome was a veritable cult, and the city consumed it in far greater volumes than many modern metropolises. The great Roman aqueducts delivered millions of liters of the purest mountain water around the clock to the baths, fountains, and private homes of the patricians. The Colosseum, as the city's main public center, was connected to this water system with the highest engineering priority. A special branch line from the mighty Aquae Claudiae aqueduct led to the building, ensuring an uninterrupted water supply to the amphitheater. Inside the walls, an extensive network of lead and clay pipes was laid, delivering water to all tiers of the building. Spectators could easily quench their thirst during long shows from the numerous drinking fountains in the galleries. But supplying the stadium with drinking water was only the simplest part of the architect's grand hydraulic engineering challenge. It was far more difficult to organize the rapid and hygienic disposal of the enormous amount of liquid waste from 80,000 visitors. The Romans built dozens of public toilets inside the Colosseum, which were connected to a continuous flush system. Streams of service water flowed continuously beneath the seats, instantly carrying all waste into deep underground collectors. No unpleasant odors, no unsanitary conditions, and no flies, the very pests that would plague medieval cities centuries later. Modern stadiums still suffer from overloaded sewage systems during halftime breaks. Let's draw a parallel with modern transformable stadiums, which can reconfigure the field for different sports. It takes weeks of hard work and millions of dollars to convert the arena from a soccer stadium into an athletics track. Complex hydraulic systems move massive stands along rails at a snail's pace, Under the supervision of dozens of engineers, the Romans flooded and drained the massive stone Colosseum in less than half a day, using only the force of natural gravity. They opened massive bronze floodgates, and the water drained away on its own through wide underground pipes into the city's sewer system. This is an example of incredible hydraulic engineering that seems almost impossible for an Iron Age civilization. The secret to such rapid drainage of the arena lies in 4 enormous drainage channels located along the building's main axis. These channels had a diameter of over 2 meters and were lined with durable, water-resistant bricks set in pozzolanic mortar. They ran at a slight slope toward the Great Cloaca, the main underground sewer supercollector of ancient Rome. When the show ended, slaves would simply lift the heavy grates, and the water would rush noisily into the underground depths. The drainage system was so powerful that it could easily handle even the heaviest tropical downpour. The building was never flooded by rainwater. All moisture instantly drained underground, leaving the stands dry. Imagine the level of hydraulic engineering required to simultaneously manage the flows of clean drinking water, processed water, and wastewater. All 3 of these independent water systems operated within a single building, never intersecting or mixing with one another. But why has our modern world completely abandoned this philosophy of timeless and reliable construction? Why are our state-of-the-art NFL stadiums built with the explicit intention of being demolished in just 30 measly years? In the next chapter, we will turn to a hard-hitting analysis of the modern construction industry and dissect this astonishing economic paradox. Prepare for the harsh truth about how capitalism has triumphed over the engineering mindset of our time. Let's transport ourselves to modern America and take a look at the magnificent American football stadiums gleaming with glass and chrome. These futuristic superstructures cost a fortune, often exceeding $2 or $3 billion per facility. They are equipped with giant media screens the size of a multi-story building, retractable fields, and luxurious climate control systems. From the outside, these sports palaces look like true pinnacles of human ingenuity and 21st century technological progress. But behind this dazzling, glossy facade lies one very dirty and carefully guarded commercial secret. The average lifespan of such an ultra-modern stadium is a mere 30 measly years from the day it opens. It sounds like complete nonsense and some kind of absurd joke, especially when compared to the Colosseum, which has stood for 2 centuries. How is it that our advanced materials and computer calculations result in a product with such a short lifespan? The famous Georgia Dome in Atlanta was built in 1992 at a staggering cost of $214 million. It was fully functional, safe, and had no structural defects or cracks in its concrete supports. However, in 2017, just 25 years after its opening, it was ruthlessly blown up with dynamite. In its place, a new, even more expensive toy was built for local sports oligarchs and fans. Why do modern sports franchise owners so easily and ruthlessly get rid of their massive stadiums? The answer lies not at all in the physical wear and tear of materials or the poor quality of modern Portland cement, as many believe. NFL stadiums do not die of old age. They die of so-called obsolescence, both moral and commercial. In the modern sports business, an arena is not just a place to play. It is a giant machine for extracting money from spectators. And if this machine stops generating maximum profit due to an outdated layout, it is simply scrapped. Capitalism has no room for sentimentality and demands constant renewal of the scenery to keep the fickle consumer's attention. Interestingly, the bulk of the cost for building these disposable sports arenas falls on the shoulders of ordinary taxpayers. NFL team owners skillfully blackmail city authorities, threatening to move the club to another state if their demands are refused. Cities are forced to issue special bonds and raise taxes to finance the billionaire's latest construction whim. Ordinary citizens pay for the stadium out of their own pockets, and then buy tickets there at sky-high prices. And 30 years later, they're asked to chip in again for a new arena because the old one supposedly no longer meets international standards. It's a brilliant financial scheme in which engineers play the role of obedient executors of someone else's commercial will. My foreman once joked that if he built a house that would last 2,000 years, his company would go bankrupt. The modern construction industry has a vested interest in ensuring that buildings break down or become obsolete as often and as regularly as possible. Constant demolition and new construction provide billion-dollar contracts, jobs, and the endless movement of vast sums of money. In the next chapter, we will delve into an economic and psychological analysis of this phenomenon of the ephemeral versus the eternal. We will understand how financial incentives are reshaping our cities and why eternal buildings have become impossible in the 21st century. We will now move on to a detailed examination of the client's philosophy, which has governed the world of architecture from antiquity to the present day. To fully understand why our world has abandoned the construction of eternal buildings, we will have to talk about pure economics. In ancient Rome, the financial system was structured fundamentally differently, and the concepts of inflation or return on investment had a completely different meaning. When the emperor embarked on a grand construction project like the Colosseum, he financed it directly from vast war booty and state reserves. He did not need to take out loans at exorbitant interest rates from international banks or issue commercial shares. He was the absolute master of all the empire's resources and could direct them toward any projects at his personal discretion. Money was spent once, but it created a tangible asset that served the state for many centuries. In our modern capitalist world, any major construction project is an extremely complex financial venture involving hundreds of investors. Money is borrowed at steep interest rates, and every dollar invested must yield maximum profit in the shortest possible time. Engineers and architects are squeezed between tight budgets and clients' demands for financial efficiency. The client doesn't need a stadium that will stand for 2,000 years, since their personal planning horizon rarely exceeds 10 to 15 years. They need to recoup the loan quickly, pay dividends to shareholders, and sell the franchise at a higher price before demand starts to fall. In this financial formula, the durability of a structure is not an asset, but a direct and very harmful economic loss. This is where things get interesting if we look at the balance between the cost of materials and the subsequent maintenance of the facility. Building a structure with the same structural integrity as the Colosseum today would cost an astronomical, absolutely prohibitive amount of money. Modern construction companies often justify the short lifespan of stadiums by citing the rapid development of new digital technologies. They say that in 30 years, technology will have changed so drastically that it will be impossible to modernize an old building. New forms of communication, holographic broadcasts, smart security systems, and automatic food delivery by drones straight to your seat will emerge. But let's be honest, all these technological gimmicks are just a way to sell the same old soccer to the audience at a higher price. The Romans didn't renovate the Colosseum every 30 years just for new types of gladiatorial weapons or trendy chariots. They created a universal, timeless, spatial platform that could easily adapt to the demands of changing eras. The Romans sought stability, order, and the permanence of their existence, embodying these values in heavy gray travertine. Their buildings served as anchors, holding society steady during political storms and brutal power struggles. Our stadiums are merely temporary commercial tents that are taken down as soon as profits from popcorn sales drop. The economic incentives of capitalism have forever closed the door on the era of grand, eternal construction for centuries to come. But beyond the dry economics, there was another crucial mental difference hidden in the minds of the ancient patrons. We are talking about the personal psychology of the Roman emperors, who saw architecture as the primary tool of their political propaganda. Why were they willing to spend colossal fortunes to delight the plebs and ensure an eternal legacy for their descendants? In the next chapter, we will examine in detail the psychological motives of the Colosseum's creators and delve into the minds of the great rulers of the ancient world. This will help us understand how the personal ambitions of a single individual can reshape the face of the planet for thousands of years to come. To understand the motives behind the Colosseum's construction, we need to delve into the complex and egocentric psychology of Roman rulers. A Roman emperor was not merely a top executive or an elected president concerned with approval ratings until the next election. He was the absolute divine ruler of a vast inhabited world, whose word held the force of an immutable cosmic law. Here, every destitute Roman could feel like the master of the world, watching the demise of exotic animals and elite gladiators. The emperor sat in full view of the entire crowd, personally controlling the lives of the fighters with a simple movement of his thumb. It was a grand, meticulously rehearsed political theater where the invisible social contract between the authorities and the people was reinforced. Roman clients demanded absolute, uncompromising quality from engineers, for any construction defect dealt a direct blow to the emperor's own prestige. If a wall of the Colosseum had cracked or collapsed during the games, it would have been regarded as a terrible divine omen. The architect and contractor of the project would instantly lose not only their fees, but also their own heads on the chopping block. Under such harsh conditions of personal liability, people built with the utmost fanatical care, double-checking every joint in the masonry. Modern builders are protected by the limited liability of their legal entities, insurance policies, and armies of expensive corporate lawyers. Interestingly, the Colosseum was built in part with funds seized during the brutal suppression of the Jewish revolt. The Roman legions plundered the richest temple in Jerusalem, carrying away tons of gold and silver and taking tens of thousands of captives as slaves. These enormous bloody trophies were converted into tons of peaceful travertine, brick, and pozzolana concrete in the heart of the capital. The architecture of the Colosseum is literally imbued with the spirit of imperial violence, conquest, and Rome's absolute domination over other peoples. The building conveyed this formidable psychological stance to every foreign ambassador or visiting merchant who entered. It was a stone manifesto of a superpower that knew no mercy and was ready to stand forever in defiance of all its enemies. It sounds ironic, but today the Colosseum brings in far more money for the modern Italian economy than it did in its heyday. Millions of tourists buy expensive tickets and souvenirs, book hotels and dine in restaurants overlooking the majestic ruins. An ancient social project designed to pacify the plebs has turned into a powerful and enduring long-term commercial asset. What important lessons from the past have we irretrievably lost in the pursuit of technological progress and quick money? In the next chapter, we will summarize the findings of our large-scale engineering investigation and articulate the Colosseum's key lessons for future generations. Let's move on to the final analysis, which will make you look at the familiar gray concrete around us in a new light. The main and most obvious lesson that the Great Colosseum leaves us is a rethinking of the very concept of technological progress. We have grown accustomed to blindly believing that each successive generation of people becomes smarter, stronger, and more technologically advanced than the previous one in all spheres of life. We look at ancient people with a slight sense of condescending superiority, considering them primitive and uneducated savages. But when we compare the durability of their structures with our disposable buildings, this illusion of progress instantly crumbles to dust. It turns out that in some fundamental areas of engineering and material science, the ancient masters were head and shoulders above us, and we need not arrogantly lecture them, but humbly emulate their ingenious, forgotten solutions. The Colosseum clearly demonstrates to us the importance of a systematic and comprehensive approach to designing large public spaces in megacities. Roman architects didn't just design a beautiful exterior facade for a building. They created a unified, perfectly balanced urban hub. They took absolutely every factor into account: soil geology, groundwater flow, crowd logistics, ventilation, and visitor psychology. Each structural element performs several critical functions simultaneously, ensuring maximum synergy and overall system reliability. Modern designers often work in isolation from one another, dividing a project into dozens of independent and poorly connected fragments. The result is a fragile and capricious structure that begins to fail at the slightest change in external environmental conditions. My grandfather always said that the true beauty of a building lies in its honesty toward the viewer and the user. The Colosseum has no fake decorations to hide structural defects, nor cheap plastic siding on the facade walls. Every arch, every pillar of heavy travertine openly demonstrates its mechanical function of supporting the colossal weight of the building. This engineering integrity gives rise to a genuine monumental aesthetic that does not become outdated with changing fashion trends and design movements. Contemporary architecture often attempts to hide its fragility and cheapness behind bright glass facades and neon lighting. But as soon as the power goes out, these futuristic boxes turn into dreary and lifeless monuments to commercial greed. But the example of the Colosseum shows that a truly smart city must be designed at the level of passive architectural solutions. A building must be ventilated by the aerodynamics of its walls, drained by the force of gravity, and stand on its own thanks to the precise geometry of its arches. Passive reliability does not depend on the stability of cellular networks, internet access, or the supply of lithium batteries for servers. The Romans created an autonomous stone machine that continues to function long after all the empires around it have turned to dust. Every design decision was tested for durability under real-world operating conditions at dozens of smaller sites throughout the empire. The modern world often uses city dwellers as guinea pigs, testing new facade materials and structural designs on them. And the price of these ambitious architectural experiments often proves too high for society. Studying the engineering secrets of the Colosseum allows us to take a fresh look at the entire history of human civilization and its main priorities. This is not just a story about old gray stones. It is a deep mirror reflecting the vices and virtues of our era. And now we will move on to the final chapter of our narrative to answer the most important philosophical question of this study. Why was the great knowledge of the Roman masters forgotten? And how can we bring this philosophy of eternal construction back to our modern cities? Let's move on to the next chapter, where history meets the future, and ancient stones offer us important advice for tomorrow. How did it happen that a civilization possessing such fantastic engineering technologies ultimately suffered a complete collapse? Where did those brilliant architects, hydraulic engineers, and masters of mixing eternal puzzolana concrete disappear to? The answer to this question lies in the tragic events of the 5th century AD, when Rome fell under the blows of barbarian tribes. The great empire collapsed from within due to rampant corruption, economic crises, and the complete degradation of state institutions of power. Along with the state, a unique system of professional education perished, one that had passed down the secrets of craftsmanship from hand to hand for centuries. This great knowledge was not deliberately destroyed. It simply dissolved into the chaos of the ensuing dark ages of European history. For many centuries, the medieval inhabitants of Rome looked upon the Colosseum with superstitious horror and a profound lack of understanding of its nature. They set up their primitive vegetable stalls, stables, and filthy shacks made of mud and sticks inside its grand arched galleries. People stripped the marble cladding from the walls to burn it into ordinary lime, destroying priceless masterpieces of ancient sculpture. My grandfather always said that you can lose a good book in a single second, but it takes many years of one's life to write it. Humanity paid a huge price for forgetting the secrets of Roman engineering, plunging into the abyss of medieval filth and epidemics. We built flimsy wooden cities without sewage systems or ventilation, which would burn to the ground from a single accidental spark. We forgot what durable concrete was and were forced to build our cathedrals from small stones held together by weak lime mortar. And only today, thanks to the methods of modern chemical and physical science, are we beginning to truly understand the wisdom of the ancient masters. This proves that true knowledge never dies completely. It merely waits for its time beneath a layer of centuries-old dust. Let's honestly admit that the modern world faces a serious choice regarding the future direction of its urban architecture. We can no longer afford to keep building disposable stadiums and skyscrapers with short lifespans. They design buildings with passive ventilation systems and natural air conditioning achieved through the shape of the walls and the placement of windows. All these green technologies, which are touted today as the cutting edge of science, were the standard of quality in ancient Rome. History has come full circle, bringing us back to the roots of the great craftsmanship of ancient builders. Summing up our long engineering investigation, we can confidently state one very important thing. The Roman Colosseum is not merely the majestic ruins of a bygone era and a popular tourist spot for beautiful photos. It is the greatest monument to human will, intellect, and systematic thinking embodied in eternal gray stone. It stands as a silent and stern rebuke to our modern, disposable civilization with its fragile values and quick profits. Ancient builders proved that humans are capable of creating structures comparable in strength to the creations of Mother Nature herself. And this stone bowl will continue to stand, reminding us of the true scale of human genius. We examined in detail all the key elements of this phenomenal ancient construction system, from the deepest foundations to the tops of the walls. We saw the ingenious pozzolanic concrete, which has been healing its own wounds with rainwater for 20 centuries. We studied the flawless geometry of Roman arches, which transformed the destructive force of gravity into a source of additional structural strength. We marveled at the 13-meter-thick travertine foundation, capable of floating during the strongest earthquakes and dampening underground tremors. And we understood how the most complex hydraulic engineering allowed the arena to be flooded for the staging of grand gladiatorial sea battles. All these elements functioned as a single, fantastically reliable, and fault-tolerant biological organism. Subscribe to our channel, give this video a big thumbs up, and be sure to share your thoughts in the comments below. Do you think we should return to building timeless structures out of natural stone and pozzolanic concrete? Or is the disposable architecture of capitalism an inevitable and necessary price to pay for our personal comfort and rapid technological advancement? We're incredibly curious to hear your opinion, because it's precisely in debates like these that a true understanding of our city's future is born. Share this video with your friends and click the bell icon so you don't miss out on new, exciting historical investigations. See you soon as we explore the vast mysteries of human civilization. Until then, catch you in the next videos.